Get it? Let's walk through it. So find the one that's 10x plus 20. I don't know if it's on the front, the back, or on the side. What do both of these terms have a letter in common?
No.
No? Okay. Do they have a number in common?
No. Yes.
What number?
0.
2 works, but that's not the biggest factor. 5 works, but that's not the biggest factor. 10 works.
Do you have to find the biggest number?
Yeah, so you have 10 times x and 10 times 2. Does everyone agree with that?
Yeah.
So what do you have in common between them right now? 10. And then you take that out, and then inside, keep all the signs the same, and do that. Questions about that one? So some of the questions were, do I have to take the biggest number? Yes, you're taking the greatest common factor out. So 10 happens to be the biggest, our greatest common factor. Can I move to the second one?
Yes.
All right, find the one that is 48x plus 30. So is there a letter I could factor out of both of them?
No.
No? What's the largest number that goes into both 48 and 30? 30 doesn't go into 48. 2 goes into both, but it's not the greatest. 6 is 6 times 8, 48. And then, how do I break 30 up using 6? 6 times 5, you agree? So what do I have in common between the two? What do I have in common between here and here? 6. And then I have 8x, keep that plus sign, plus 5. Done. So you're undistributing is what you're doing. All right? Any questions on that so far? All right, let's take a look at this one. Do both terms have a letter in common? Yeah. Do both terms also have a number?
Yeah.
No.
What goes into 7 and 8 both? Well, I guess 1 does, but we don't worry about 1. So they both have an x. So this is the same thing as 8xx, because 8x squared is x times x. So what can I factor out of both of those terms? X. If I factor a single x out, what do I have left right here? 8x. Plus sign comes down. If I factor an x out of that, what do I have left? Done. Okay. And the last one. Do both terms have a letter in common?
Yes.
Yes. Do both terms have a number in common?
Yes.
Yeah. What number goes into both 16 and 10? 2. 2? That's 2 times 8. And then x, right? And that's 2 times 5, x. So I have a 2 in common between them. What else?
X.
I have an x. Do I have another x as well? Sure do. So x is x squared. So what do I have left if I take a 2x squared out of that first one? 8x. Good. Plus sign comes along. What do I have left on that second one? 5. So again, I undistributed. I undid the distributive property. That okay? Okay, so that's kind of just starting out. Put that away. It's I poked holes in it so you could put it in your notebook if you'd like. Let's get out page 27 and 28, if you don't mind. You'll have to probably grab a different book to accelerate your book. What kind of questions did we come on with number page 27, the first page? Yes, sir. 16. All right, number 16.
Oh, actually, can you do 23?
23, sure. 23. 14. A squared b to the third minus 7a b to the fourth plus 21 a to the third b to the second. Did I write it down correctly? Okay. Is there a number that goes into to 14, 7, and 21, other than 1? 7 does. Okay, so if I break that to 7 times 2, and then I have A, and then B, minus 7A, B, 2, 3, and then 21 is 7 times 3 times 1, 2, 3, B. That's supposed to be on the same line, but it ran out of space. So you said, what did I do?
You had 2 A's.
Yeah, you added 3 A's to the first one.
Right next to 7 times 2.
Oh, good keen eye. Thank you for watching out for me on that. Okay. So y'all said I have a 7 on all 3 of my terms. Agree? So that comes out front. Not the 2 or the 3. They have to stay there. How many A's can I factor out of all 3 terms? I have this one, and I have this one, and I have this one, right? So there's a single one. How many B's can I factor out? What's the maximum number of B's that all 3 terms have? 2. So I got 1, 2, and 1, 2, and 1, 2. So B squared comes out front. Now we're going to do the parentheses. So what do I have left here if I had factored out a 7ABB? What's left under there? 2. What else? And an A and a B. Cool. A 2, an A, and a B. Subtraction sign comes down. What about this next set here? What if I factor a 7 out and a B, A, and a B, and a B? What do I have left there? B squared. There's, okay. Then plus sign comes down. If I factor out a 7ABB from the last term, what do I have left? 3A squared. And that's it. If I redistributed this to all 3 terms, I'd come up with my original blue one. What else from the homework would you like to take a look at? Yes?
21.
2, 1?
Yeah.
Okay. 21. Is that the right one? Cool. All right. What does the largest number that 14 and 21 all have in common? 7. I'm going to make this 7 times 2, A, B, B, plus 7 times 3, A, B, B, B. Agree so far? So you said I could pull a 7 out. What else can I pull out of both terms?
AB.
I can pull an A. How many B's can I pull out of both? 2 of them. BB. BB. All right. So 7AB squared root. Or I don't know why I put a square root sign. I'm just like making up math as we go along. All right. Parentheses. If I take a 7ABB out of the first, what do I have left? What do I have right? 2. Plus sign comes down. If I take a 7ABB out of the second one, what do I have left? 3AB. Cool. Agree? Done. Yeah. 2, 4, yeah. We have x to the 4th, y to the 3rd, z to the 5th, plus x squared, y to the 5th, z to the 3rd. Okay, numerically, is there a number I can pull out of both those terms? I guess a 1, but that doesn't really help us out. So let's, nothing to pull out as far as numbers. So this first one is x, y, z, plus x, y, 2, 3, 4, 5, and then 1, 2, 3. Okay, I ran out of room, so I had to put it down there. Is that okay? All right, so let's look at the x's first. What's the maximum number of x's I can take out of both of those terms? 2 of them. Take those 2, take those 2. So I get x squared outside. Is that okay? What's the maximum number of y's I can take out of the two terms?
3.
3 of them. So 1, 2, 3, and 1, 2, and 3. So that's y to the third outside. What's the maximum z's I can take out of both terms?
3.
3. So I got 1, 2, 3, and 1, 2, 3. That's z to the third. Sweet. So if I take all those out, what do I have left? I have xx and 2 x's and 2 z's, so I have x squared and z squared. Bring the plus down. What about that last one? What do I have left? Y squared. Done. All finished. Anything else from that worksheet you want to take a look at? Yeah.
Sophie was also reading her hand, so it's okay.
Oh,
Okay.
I didn't-
14.
14, and then Sophia, which one do you want?
25.
25 and 14. Okay. 25 and 14. Okay, number 14 is 3x squared plus 6x plus 9. Okay. What is the largest number that 3, 6, and 9 all have in common? 3. Can I factor a letter out of each one? So this is 3xx, this is 3 times 2x, and that's 3 times 3. Agree? So they all have a 3 in common, nothing else though. That's done. Did I do it right? I hope. Because all I factored out was a 3. And then the other one was 25, you said? Okay. So they tell us that we have the area of this rectangle is 6x to the third plus 3x squared plus 12x. And they have this rectangle drawn for us. One of the sides is 3x, and we want to know what the other side is. So what does it appear that I'm when I find the area of a rectangle, I multiply a length and a width, or a side times a side. Agree? So this is saying, hey, I'm going to multiply 3x times something to get this. So what am I factoring out of all of those?
3x.
3x. It might not be the biggest factor. So let's take this down. That's going to give me 3 times 2x, x, x. And that's going to give me a 3xx and a 3 times 4x. So if I factor a 3x out of here, I get this and this, this and this, and this and this. So what do I have left? What do I have left right here? 2x squared, good. Plus sign. What do I have here? X. And then what do I have here? 4. That's 4. Done. So the missing side is x squared plus x plus 4. I think I answered that question all the way. Oh, find the area if, excuse me, hiccups. Find the area if x is actually equal to 2. So what do you think I should do with this? If they tell us that x is equal to 2, how do I find the exact area? Well, yeah, I'm going to change. So every place that I had an x, every place I have an x, I'm going to replace it with a 2. All right, so let's see. I have area equals 6 times 2, and 2 is to the third, plus 3 times 2 squared, plus 12 times 2. Is that okay? Where those 2's are were x's. Then we kind of have to do the math that goes along with it. What is 2 to the third power? That's 2 times 2 times 2. 2 times 2, it's 8, right? 2 times 2 is 4, times another 2 is 8. And then this is going to be 3 times 2 squared is just 4. And that's going to give me just 24 right there. Let's help this out. That's 48 plus 12 plus 24. Add it up. 48 and 12 is 60. 60 and 24 is 84 square units. Could be square inches, square miles, square feet, I don't know. Anything else from the homework you need me to cover? Make sure your name is on it, and if you're handing that and as well as anything else handed it in, please pass it on forward.
Oh.
This is the homework due over the weekend.
Yeah, buddy. Thank you.
Totally.
I don't do those checks, so you just cycle them every day. That's your prerogative. Put it in the notebook, great. You just stuff them in your sock, great. Reverse card. Perfect. I'll let you
Okay. Yeah, we'll go over it. Make sure you keep me on. All right, everyone have a note page? Okay. What are they? All right. Let's see what these notes have to say for us today. All right, so we're going to be graphing or factoring by grouping. That means that we kind of have like some whole big thing that we're going to take out of stuff. So if we start out with these, we can do this. So some of you might see, what's the biggest number I can take out of both of those? 4. So that's 4 times 4 times x minus 4 times 3 times y. So I can pull a 4 out, and I'm left with 4x minus 3y. I couldn't take a letter out of both because they were different letters. Okay, so we're just kind of warming up. We've already seen this a little bit. What about a number 2? What does it look like I could take out of both terms? Yeah, they both have an x in common, so I pull an x out front, and it leaves me y plus 2. Right? I think I have it notes on your desk, yes? Cool. And then what about this last one? They both, well, so that's x, y, y, and that's 2xy. What do they have in common between them? An x and a y. So if I take an x and a y out of this first one, I have a y left. Plus, if I take an x and a y out of this last one, I have a 2 left. And there's that answer. So I'm reverse distributing, right? Seem okay? Okay. May I move on? Good. All right. All right, so on this one, if you look at the blue, they had this originally, and then they said, hey, we want to take this and this and plug it in for the x values now. So now I have something grouped that we have in common. So if you look at these, I have an x plus 3 and an x plus 3 in common between the two. I have this and I have this between the two. So if I factor x plus 3 out, are there things left behind? If I factor an x plus 3 out of both, is there something we leave behind? So what did I leave behind on this one? A y. And the plus, what did I leave behind here? 2. Done. So factor by grouping. Factoring by grouping has actually become a very powerful tool for you as we start progressing through factoring a trinomial, which will actually start tomorrow. Any questions on that? Good? Okay. Can I move on? All right. All right, so let's look at this next one. So I'm going to highlight what we have in common between the two. I have this and I have this. Agree? So I'm going to factor out that whole thing. So I'm going to factor x minus 1 out of both of them. If I factor x minus 1 out of this, what do I have left? 2x, and I'm going to regroup it. If I factor x minus 1 out of that, what do I have left? Plus 5. Done. What do you think? Seem okay? Am I confusing anybody? And I know some of these things you might be looking at going, why am I bothering doing it? Well, the skill that you're learning from this will actually really apply with the future stuff that we're going to be working on these, okay? Can I move off the screen?
Yes.
Yeah.
All right, talk to me. What do I have in common between those terms?
X and 5.
X plus 5? Everyone comfortable with that?
Yes.
An x plus 5 here and an x plus 5 here. All right, so if I factor x plus 5 out, if I factor it out of here, what do I have left?
3x.
3x. And if I factor it out of here, what do I have left?
Minus 2.
Oh, thank you for carrying the negative. Good job. That's done. That is all done. How many more pages I got?
3.
Yeah,
I have 3 slides or 3
Yeah,
pages? 3 slides.
3 slides. 3 slides.
Okay, I think we can make it. Hey! It's 1, 2, 3, 4.
Oh, yeah.
All right, ready? What does it look like we have in common on this one?
2x plus 3.
2x plus 3, and there's a little trick on this one. So everyone agrees with this, I think. Yes?
Yes.
All right, so I factor 2x plus 3 out. What do I have left here?
X minus.
X, and then what do I have in common here? A minus. What's a placeholder?
1.
1. That's it. Nailed it. So technically there would be a 1 right there. Okay? Factor by grouping. You're taking out like a whole equation. Multiple terms. Any questions so far? Yeah.
It's like random, but what would happen if you put the negative like before the x?
Oh, so if that was negative then 2x plus 3, negative x and then 2x plus 3?
No, it would be like negative and then x, and then parentheses.
Oh, we're going to see one. I bet you we'll see one. If not today, tomorrow. Okay. Can I move on? Okay. This one we don't have something already grouped together. Agree? But how many terms does it look like I have right here? How many different terms do you think there are? 4. Right? I have x to the third, that's a term. I have x squared, that's a term. I have 7x, that's a term. And I have 7. That's a term. Okay? So how you're going to approach this is when you have 4 terms, you're going to look at your first 2 terms. And I'm only going to look at the first 2 terms right now. What do I have in common between those first 2 terms? X squared, right? Because the first one's xxx and the second one's xx. So between these 2 terms, I have an x squared in common. If I factor an x squared out of both of those, because that was xxx and that was xx, right? If I factor an x squared out of this, what do I have lie here? X, and then the plus comes down. If I factor an xx out, both of them come out. What has to go in for a placeholder? 1. So that first part's done. So I look at the first terms, see what they have in common. Then I'm going to look at this next one. Okay, just the underlined in purple. What does it look like I have in common between the 2?
7.
7, and is it positive or negative 7?
Positive.
Positive. So I have plus 7. So if I factor 7 out of 7x, I'm left with x. That plus comes down. If I factor 7 out of 7, what's a placeholder?
1.
What do I have in common between those now?
1 and x. X plus 1.
X plus 1. So now, when you have 4 terms, it comes down, it breaks down to what we've been working with. So then you're going to look here. You take that and that, factor those out. What do I have left? So what comes out?
X squared.
X plus 1, what's left? What's left?
X
X
squared
squared
plus
plus
7.
X squared plus 7, that's it. Done. So if you have 4 terms, you look at the first 2, factor the maximum out. Look at the next 2, factor the maximum out, and then it breaks down to what we were just working on. You have this grouped thing. You have something with parentheses. Any other questions so far? Seem okay? Can I move on? Is this the last slide?
Yeah.
Really? Oh man, I hope we got one more after this. Okay. Man, I hope we get cupcakes or something when we get done. All right. So first thing I'm going to say, how many terms do I have up there?
4.
4. So I'm going to look at these first 2 only. What do I have in common between those first 2? 4.
X squared.
4x squared, right? Because this is 4x, x, x, and this is plus 4 times 3xx. So if I factor a 4x squared out, what do I have left here if I factor 4x squared out? What's left right here?
X.
X, and then plus. If I factor a 4x squared out of that, how much do I have left? Just 3? Is that all right? Okay, so let me just pause. Does that feel okay? All right. There's something that's going to happen on this board, and we need to we're going to do something like this. This means it's a special kind of board. And I know some of you want me to color the whole thing in. You're like, dude, this is the best. But now we have it awkward. It's like, dude, come on! I know, I'm sorry. So something special is going to take place here. Okay? Yes. Do that. Yes. All right. It's a little too dark. I don't want that dark. Green brick. Let me just do this. I'm just boxing that in right there. See that part right there? Okay. So I want you to notice something. You notice my third term is negative. Agree? I have negative 3x minus 9. So I can factor out a negative 3. And then I'm going to get, if I factor a negative 3 out of that, what's left? X. If I factor a negative out of a negative, it turns positive. If I factor a negative 3 out of negative 9, what do I have left right here? Positive 3. Okay? Do I have this and this being the same? Yeah. So then let's go ahead and say, well, I can factor an x plus 3 out. And then what do I have left? 4x squared and minus 3. That's done. That's done. All right. So your assignment for tonight, we did 25, 20, or 27, 28. Let's do page 29 and 30. Page 29 and 30. If you don't have a book yet, maybe take a picture of your friends and copy it on a piece of notebook paper. But that is all I have for you. I wish I had more. I apologize for that.